Hello everyone, this is Brad with Oomlout's Experimenter's Guide for Arduino. This is Project 5. We'll be working with the integrated circuit shift register to control 8 LEDs. This is a 74HC595 shift register integrated circuit, and we have it set up currently as a 8-bit binary counter. As you can see, it's counting up to 256 currently, and as usual we have the power and ground here, running to power and ground on the board, and then we're also using both power and ground buses on each side, so power is routed across them over here, and then this interconnect in here. Let's see if we can zoom in a little bit on that without it getting blurry. Nope. Right here we have pins 1 through 8 and then 9 through 16. And pins 1 through 6 and 15 are Q0 through 7, which are the 8 output pins, making it an 8-bit IC. Pin 16 is voltage, or your 5-volt power, and then pin 8 is ground. And as we see here, we have the data pin, pin 14, connected to pin 2 on the Arduino. The latch pin 12, is connected to pin 4 on the Arduino, and then we have the clock set to pin 3 on the Arduino, and we'll be sending various codes to each of them to control the LED states. And then each LED is connected to Q0 through Q7, so pin 15 and pins 1 through 7. Okay, and here we have the code. This is available at ardx.org/code05. We have here set up the data pins, the 3 that we'll be using, pin 2, 3, and 4 outputs on the Arduino. We have the data, clock, and latch, and those are stored as these integers here. Then here we have set up for the LED manipulation. LED state is another integer we've introduced, and here we have const, or constant integer, and then this on is set to high, offset to low, and this const function here sets this integer on so that it's unchangeable. No other piece of code can change it. Void setup, we set the pin modes as outputs. The void loop, this first function here, we have a 200 millisecond delay time between LED updates, and then a for loop counting from 0 to 255, or so it counts to 256, so 0 to 255 or 1 to 256 as shown on the LEDs, and that reflects the 8-bit count in binary. And then update LEDs, and then a delay time of 200. And this second part here, update LEDs long, is basically exactly the same as this. It's just written out what is happening in this shift out function, and we're counting 0 to 8 and shifting values with most significant first, and shifts a value 1 to the left. And for further understanding of how bitwise operation works, it's a little bit hard to explain without actually drawing things out, so I would recommend going to the bitwise operation Wikipedia page, as well as checking out some videos on how shift registers work on YouTube. It's a little easier to understand, but basically you send a chunk of 8-bit information out to the shift register, close the latch, and it pulses the clock cycle, and then updates the LED states. So each time it counts up 1, it changes the state of the LEDs on, so it will then move on to the next count in the binary count. And then here we have just the bitwise math integers arrays used in the shift functions, and then the change LED here. This is actually what is used to change the LEDs. We mask all of the counting up until the last, the final count has been finished in this up to 8 count. So we just see the final actual 8-string value is sent to this LED state update. So we don't see it using the most significant bit counting to reach that final 8-bit piece of information. We just see the final piece after this function is completed, and then that's sent to the change LED, and then it updates the LED state and cycles back to the beginning loop here and counts up to the next, and then it runs again.